Hello students, I am Dr. R. Krishnakumari, Assistant Professor, Department of Mathematics, Faculty of Engineering and Technology, SRM Institute of Science and Technology, Katanguluttur. Today we are going to see about theory of sampling and testing of hypothesis. So the outline of today's session is going to be, we are going to see about two samples, small samples and large samples. In small sampling, we are going to see about student t-test for single mean, student t-test when standard deviation is not given, and student t-test for difference of means of two samples. Then it is going to be followed by f-test, and last we are going to see about chi-square test. In large samples, we are going to see about the test of significance for single proportion, then the test of significance for difference of proportions, then the test of significance for single mean, followed by test of significance for difference of means. So before going into the major sampling methods, first let us see about certain basic notions that are essential for understanding this testing of hypothesis. So what is meant by population in sampling? Group of individuals under study is called as population, and a finite subset of statistic individual population is called as sample. Individuals in a sample is named as the sample size. Statistical population are referred as parameters, and the statistical concept of the sample are referred as statistics. The standard deviation of sampling distribution of a statistic is known as its standard error, and it is denoted by SE. So what is meant by test of significance? It enables us to decide on the basis of the sample results if the deviation between the observed sample statistic and the hypothetical parameter value is significant, or deviation between two sample statistics is significant. A null hypothesis is nothing but a definite statement about the population parameter, which is usually a hypothesis of no difference, and it is denoted by H naught. Any hypothesis which is complementary to the null hypothesis is called as an alternative hypothesis, and it is denoted by H1. There are two types of errors in sampling. Type 1 error is rejection of null hypothesis when it is true, and type 2 error is going to be acceptance of null hypothesis when it is false. A region corresponding to a statistic T in the sampling space S which lead to the rejection of H naught is called as critical region or rejection region. Those regions which lead to the acceptance of H naught are called acceptance region. Probability alpha, random variable of the statistic T belongs to the critical region, is known as the level of significance. So the level of significance usually employed in testing of hypothesis are 5% and 1%. So there are two types of tests, one tail and two tail test. A test of any statistical hypothesis where the alternate hypothesis is one tail, that is a right tailed or a left tailed, is called one tailed test. So for the null hypothesis H naught, if mu is equal to mu naught, then H then H1 is equal to mu greater than mu naught is said to be a right tail, and H1 equal to mu less than mu naught is said to be a left tail. And if H1 is equal to mu not equal to mu naught is said to be a two tail test. So in the sampling, types of samples is going to be small sample and large sample. So for small sample, the count n is going to be less than or equal to 30. And as I said before, student t-test, f-test and chi-square test are going to be the small samples. And in large samples, n is going to be greater than 30 and z-test falls under large samples. Small samples. So if the size of the sample n is less than or equal to 30, then the sample is called as small. So first let us see about the type 1 student t-test for single mean. So the modulus of t is equal to x bar minus mu by s by root of n minus 1, where here the x bar denotes the sample mean, mu denotes the population mean, s denotes the standard deviation, and n denotes the number of observations. Now let us see a sum in it. The mean weekly sales of soap bars in departmental stores were 146.3 bars per store. After an advertising campaign, mean weekly sales in 22 stores for a single week increased to 150.7 and showed a standard deviation of 17.2. Was the advertising campaign successful is the question. So the calculated p value is going to be 1.97, whereas the tabulated value is going to be 1.75 percentage level of 20 degrees of freedom. Since the calculated value is greater than table value, so we are going to reject null hypothesis. Let us see another sum. A sample of 26 bulbs gives a mean life of 990 hours with a standard deviation of 20 hours. The manufacturer claims the mean life of bulb is 1000 hours. Is the sample not to the standard question? So the calculated t value is equal to 2.5 and the tabulated value is equal to 1.708 at 5 percentage level of significance with 25 degrees of freedom. Since the calculated value is greater than tabulated value, the null hypothesis is rejected. The average breaking strength of steel rod is specified to be 18.5 thousand pounds. To test this sample of 14 rods was tested. The mean and standard deviation obtained were 17.85 and 1.955 respectively. So is the result of the experiment significant? So the calculated t value here is going to be 1.199 and the tabulated value is going to be equal to 2.16 at 5 percentage level of significance with 13 degrees of freedom. So since here the calculated value is less than the tabulated value, we accept the null hypothesis H naught. Now let us see type 2 student t-test when standard deviation is not given. So the formula for this is going to be mod of t is equal to x bar minus mu divided by s by root of n, where x bar is equal to summation of x by n and s square is equal to 1 by n minus 1 sigma x minus x bar the whole square. A random sample of 10 boys had the following IQs: 70, 120, 110, 101, 88, 83, 95, 98, 107, and 100. Do these data support the assumption of a population mean IQ of 100? Find reasonable range in most of the mean IQ values of sample of 10 boys lie. Calculated t value here is going to be equal to 0.62 and the tabulated value is 2.26 at 5 percentage level of significance. 9 degrees of freedom. Since the calculated value is less than the tabulated value, we accept the null hypothesis. The heights of 10 males of a given locality are found to be 70, 67, 62, 68, 61, 8, 70, 64, 64, 66 inches. It's reasonable to believe that average height is greater than 64 inches. So they have asked us to set 5 percentage. So here the calculated p value is equal to 2 and the tabulated value is equal to 1.833, 5 percentage level of 9 degrees of freedom. Since the calculated value is greater than the tabulated value, here we reject null hypothesis. Next, we are going to see about the type 3 student t-test for difference of means of two samples to test the significant difference between two means n1 bar and x bar sample sizes n1 and n2. We use the statistic mod of t is equal to x1 bar minus x2 bar divided by s into root of 1 by n1 plus 1 by n2, where s square is equal to n1 s square plus n2 s square by n1 plus n2 minus 2, and here s1 and s2 be the sample standard deviations and the degree of freedom being n1 plus n2 minus 2. So now let us see a problem based on this type. Sample of two types of electric light bulbs were tested for length of life and the following data were obtained. So is the difference in the mean sufficient to warrant that type 1 is superior to type 2 regarding the length of line? So from the given table, it is evident that the calculated p-value is going to be 9.6 and the tabulated value is 1.77 at 5% level of significance with 13 degree of freedom. So here, since the calculated value is greater than the tabulated value, we reject null hypothesis H naught. Next, we are going to see about F test. So to test if the two samples have come from the same population, we use F test, or to test if there is any significant difference between two estimates of the population variance, we use F test. So F is equal to greater variance or smaller variance, or F is equal to S1 square by S2 square, where S1 square denotes summation of x minus x bar the whole square by N1 minus 1, and S2 square denotes the summation of y minus y bar the whole square by N2 minus 1, where N1 is the first sample size and N2 is the second sample size. So applications of F test: to test whether there is any significant difference between two estimates of population variation, and it is used to test if the two samples have come from the same population. And the uses of F test in sampling is that it is used to test whether there is any significant difference between two estimates of the population variance, and it is also used to test if the two samples come from the same population. And if the sample variance S square is not given, we can obtain the population variance by using the relation S1 square is equal to N1 S1 square by N1 minus 1, and similarly to for S2 square. And if we have to test whether the samples come from the same normal population, then the problem has to be solved by both t-test and f-test. To test the equality of the variance, we are going to use f-test, and to test the equality of means, we are going to use t-test. Now let us see a problem in F-test. Two random samples gave the following results. So they have mentioned the sample size, sample mean, and sum of squares of deviation from the mean. They have asked us to test whether the samples come from the same normal population. So the calculated F value from the F table is going to be 1.018, and the tabulated F value is going to be 2.9 from the table at 5% level of significance with 9, 11 degrees of freedom. So by t-test, the calculated t-value is going to be 0.74 and the tabulated value is going to be 2.086 at 5% level of significance. So since both in f-test and t-test, the calculated value is less than the tabulated value, therefore we accept the null hypothesis. Next, we are going to see about chi-square test. So chi-square is equal to summation of O minus E the whole square divided by E, where O is the observed frequency and E is the expected frequency. Chi-square test for independence of attributes is that an attribute means a equality or a characteristic. For example, drinking, smoking, blindness, honesty, everything comes under the category of attributes. So consider any true attributes A and B, then A and B are divided into two classes such that I have given here how the observed frequencies will look like and how the expected frequencies is going to be calculated. Now let us see a sum based on it. A die is thrown 264 times with the following results. Show that the die is biased. So in the table they have appeared the number appeared on the die and the frequency. So the calculated chi-square value is going to be equal to 17.362 and the tabulated value is equal to 11.07 and 5 level of 6 with 5 degrees of freedom. Since here the calculated value is greater than the tabulated value, we reject null hypothesis. Given the following table for hair color and eye color, so find the value of chi-square and is that there is any good association between the two. So the calculated chi-square value is going to be equal to 3.6458 and the tabulated value is 9.488 at 5% of significance level with 4 degrees of freedom. Since here the calculated value is less than the tabulated value, we accept the null hypothesis. Next, we are going to see about large samplings. So if the size of the sample is greater than 30, then that sample is called as, So first we are going to see about the test of significance for single proportion. Let P be the sample proportion and the capital P denote the population proportion. Then we use the statistic Z equal to small p minus capital P divided by root of PQ by N, where the limits of the population proportion P are given by P plus or minus 3 root of PQ by N, and the relationship between P and Q is that Q is equal to 1 minus P. So now let us see sums based on this. A manufacturer claimed that at least 95% of the equipment which he supplied to a factory conformed to specifications. An examination of a sample of 200 pieces of equipment revealed that 18 were faulty. So test is claimed at 5% level of significance is the question. So the calculated Z value is going to be equal to 2.59 and the tabulated value is going to be 1.96. So since the calculated value is greater than the tabulated value, we reject the null hypothesis. Similarly, in the next question, they have mentioned that in big city, 325 men out of 600 men were found to be smokers. Does this information support the conclusion that the majority of men in this city are smokers? So we are going to calculate the Z value, which is going to be 2.04, and tabulated value is going to be 1.45 from the Z table at 5% level of significance. Here the calculated value is greater than the tabulated value, we reject the null hypothesis. Next, we are going to see about the test of significance for difference of populations. So let N1 and N2 are the two sample sizes and the sample proportions are P1 and P2 such that Z equal to P1 minus P2 divided by root of PQ into 1 by N1 plus 1 by N2, where P is equal to N1 P1 plus N2 P2 by N1 plus N2, and the relationship between P and Q is going to be Q equal to 1 minus P. So let us see a sums based on this type. Before an increase in excise duty on tea, 800 persons out of the sample of 1000 persons were found to be tea drinkers. After an increase in duty, 800 people were tea drinkers in the sample of 1200 people. So using the standard error of proportions, state whether there is a significant decrease in the consumption of tea after the increase in the excise in the existing duty. So the calculated Z value is going to be 6.972 as per the Z formula, and the tabulated value at 5% is going to be 1.645. So since the calculated value is greater than the tabulated value, we are going to reject null hypothesis. Next, let us see the type 3 test of significance for single mean. So z equal to x bar minus mu divided by sigma by root of n, where x bar denotes the mean, mu denotes the population mean, s denotes the population standard deviation, and n is the sample size. The values of x bar plus or minus 1.96 sigma by root of n are called 95% confidence limit for the mean of population corresponding to the given sample. And values of x bar plus or minus 2.58 sigma by root of n will give 99% of confidence limit. Now let us see a sum based on this type. A sample of 900 members has a mean of 3.4 centimeters and standard deviation 2.61 centimeters. So, if the sample from a large population of mean is 3.25 centimeters and standard deviation 2.61 centimeters, and if the population is normal and its mean is unknown, find the 95% confidence limits of true mean. So, the calculated Z value is going to be 1.724 and the tabulated value at 5% is going to be 1.96. Tabulated value is greater than calculated value, we accept null hypothesis. Next, we are going to see the last type, test of significance for difference of means. So, z equal to x1 bar minus x2 bar by root of sigma 1 square by n1 plus sigma 2 square by n2. So, the means of two large samples, 1000 and 2000 members at 67.5 inches and 8 inches respectively. Can the samples be regarded as drawn from the same population of standard deviation 2.5 inches? So the calculated Z value is 5.16 and the tabulated value at 5% is going to be 1.96. So the tabulated value is less than the calculated value. Therefore, we reject the null hypothesis. So thank you, students. Let us join again in another interesting session. Thank you.